Hello and welcome to helpyourmath.com. In this video, we're going to look at examples of condensing logarithmic expressions. First, we'll just quickly review the properties of logarithms. And I say quickly because there is a previous video where I do go over these in more detail. It's just good to know them right up front. And if you know them, say them with me. So first, when we are talking about a logarithm, we have log base b of this thing. This thing is the base. The base is always a positive number. And this here is called our argument. So when we're in logarithmic form, this thing is called our argument. Okay, same base multiplication just says that if we have log base b of x times y, so there's a product in our argument, we can rewrite it as log base b of x plus log base b of y. And actually, as we're going through this, we're actually doing the reverse. So, I mean, it's not the reverse, it's just the commutative property. So we're basically going to be given this, and we want to write it as this. For same base division, I'll write it the way that we're going to be seeing it in this video. That would be log base b of x minus log base b of y. And we're going to rewrite that as log base b of x over y. Basically what the same base division is saying is if there's a positive coefficient, that particular piece will be in the numerator of the argument. If it comes after a subtraction, that piece will be in the denominator of the argument when you go to combine them. And then lastly, power to a power. So the way that we're going to see this is if we have y times log base b of x, we're going to rewrite it as log base b of x to the y. It becomes the power of the argument. Let's look at some examples. In our first example, we want to write as a single logarithm of the form log base b of x. So you'll notice here that the coefficient of our logarithm is 1, and we want everything in the argument. So we want just one single logarithm. One single logarithm. We don't want to say log base b over log base b. That is incorrect. Okay, so here's what I'm noticing. We don't have any coefficients to worry about, but we do have some subtractions. Remember what the subtraction means? That means that those pieces will be in the denominator of that one single argument. So we write normal size log base 2, and then we're going to have a in the numerator, and we're going to have s times p in the denominator. Because they both come after subtractions, and that's all we can do to condense this logarithm. So we're done. Not so bad, right? Okay, it's a little bit trickier this time. So this time we have to deal with the fact that we have the coefficients. First, deal with the coefficients. What happens with those? They become the powers of the arguments. So we're going to rewrite this as log base 3 of x to the 4/5 minus log base 3 of z to the 2nd power. Now that we have coefficients of 1 and we have the same base, right, they're both base 3, we can now combine them into one single logarithm. So this becomes log base 3, and then what's my argument? Well, in the numerator, I have x to the 4/5. In the denominator, I have z squared. So we have one single logarithm. Notice I didn't write the logarithm twice. And we have x to the 4/5 in the numerator and z squared in the denominator. For me, personally, I'm fine if you leave it like this. But because, when we went the other direction, we sometimes had radicals. If you want to rewrite the numerator as a radical, that's fine. I'm sure that's mostly unnecessary, but just if you want to just show how skilled you are, what this would be, that 5 will become the index of the radical, x to the 4th would be under the radical, and then you'd have z squared. I would say if you don't have to do that, don't, but it's okay if you feel the need to, fine, go for it. Okay, what about in this example? We have 2 times log base m plus 3 times log base n. Sorry, wait, I'm saying base. There's no base given. What does that mean when there's no base given? That means that it's base 10, and we don't have to write base 10. Base 10 is like our identity. The same way we don't write 1x all the time, we just write x. If there's no base given, it's assumed to be base 10. So let me try reading this one again. 2 times log of m plus 3 times log of n minus 1/4 times log of p. The first thing I'm going to deal with here are those exponents. So we're going to rewrite this as log of m squared plus log of n cubed minus log of p to the 1/4. Okay, now I'm ready. Now that I have coefficients of 1s and they all have the same base, right? They're all base 10. I can combine them into one single logarithm. So we're going to have log, and we're going to have a fraction because I see a subtraction sign. So we have m squared in the numerator, n cubed in the numerator, and p to the 1/4 in the denominator. And again, if you really want to wow your instructor, you could write it as log of m squared n cubed over the 4th root of p. I say the less work you have to do, the better, because what happens if you make a mistake in that final step? How frustrating is that? And in our final 2 examples, I encourage you to pause the video, try them out for yourself, and see how you do. All right, let's look at our first example. We have some coefficients. So to deal with those coefficients, we're going to write them as exponents of the arguments. So this will become log base 6 of f to the 1/3 minus log base 6 of g to the 2/5 plus log base 6 of h to the 2/3. Now that they all have coefficients of 1, we can combine them into one single logarithm. So this will become log base 6. And then remember, anything that has a positive coefficient goes in the numerator, anything with a negative coefficient goes in the denominator. Looking at each term separately, f to the 1/3 will go in the numerator because its coefficient is positive. G to the 2/5 has a negative coefficient, so it goes in the denominator. H to the 2/3 has a positive coefficient, so it goes in the numerator. Sometimes we get stuck on the fact that there's that plus sign between G and H, and we think, wait, no, it should be with G, but that's not true. We could use some properties and kind of rearrange things, the commutative property, for example, and the plus sign would stay with the H and the minus sign would stay with the G. So because there's a plus sign directly in front of H and there's no indication that the negative belongs to H at all, H goes in the numerator. Okay, I'm fine if you leave your answer like this, but if you want to get fancy pants on me, we could rewrite it where we rewrite the denominators of the exponents as indices. So we could write this as log base 6 of the cubed root of f times the cubed root of h squared over the 5th root of g squared. And if you want to get even fancy pantsier, you could even put the 2 radicands here under one radical. So we would write this as log base 6 of the cubed root of fh squared. We can't do that with the denominator because it is a different index, so those would have to stay separate. I encourage you to do less work when you can, so I don't encourage doing the final 2 steps, especially because there's nothing worse than getting it wrong. Sometimes what I've seen students do when they're so proud they can do it, and it's great, and I love that, but then they forget to write log base 6, and that technically is not correct. So that's why I say less is more. Less is best. How about that? Okay, in our final example, we have no coefficients, so we can go right into writing this as one single one single logarithm. This will be log base 2, and this has a positive coefficient, so x minus 3 is a factor of the numerator. This has a positive coefficient, so x is a factor of the numerator. This has a negative coefficient, so it's going in the denominator. Negative coefficient going in the denominator. Okay, so yay, this looks good. It's tempting to want to distribute the x in the numerator. However, I notice that we do have a common factor between the numerator and denominator, and we want to actually factor it out. So don't distribute. Instead, look here. We have a factor of x in the numerator and a factor of x in the denominator. Those will simplify out, leaving us with log base 2 of x minus 3 divided by 3. And that's what we should do. Now, I always say less is more, but in this case, because we can simplify the fraction. So you do want to take that one single step. If we couldn't, if they didn't have a common factor, if that was like x and then a y in the denominator, I would just leave it in factored form. I wouldn't distribute still. I would just leave it as is. But because we could simplify, we did. These have been examples of writing logarithms as a single logarithm. Thank you for stopping.